Hey everyone, Mr. Newman here, and I'm going to show you guys the first part, the multiple choice part of the factoring review test. So let's get started. For this first problem, we're going to just multiply, and if we just have a monomial times anything, we're going to distribute it. So we do 4 times 3x, that's 4xy times 3x, so 4 times 3 is 12. X times x is x squared, and the y will also be multiplied there. Minus 2 times 4 is 8, x times x is x squared, and the y times the y is y squared. And the last one is 4xy times 10 will be 40xy. So don't forget that 4 and the x and the y all together gets multiplied and distributed to each of the 3 terms inside the parentheses. For the next one, we're multiplying 2 binomials. Notice I write this on the outside of the box. This is the opposite of the factoring we've been doing lately, so make sure you can multiply it out and go that direction too. When you multiply, 3x times 2x is 6x squared. 3x times 1 is 3x. Negative 5 times 2x is negative 10x. And negative 5 times 1 is negative 5. When you add all those together, the 3x and the negative 10x get added together to become negative 7x. So that middle term is negative 7x, which makes the answer C. For the next one, we're again multiplying 2 polynomials. This time it's a binomial times a trinomial. The only difference from the last one is that we need to draw the box, make it a 2 by 3. That way we can fit the binomial there on the left and the trinomial across the top. And so let's multiply each of these. So you multiply to get in the box. 4x squared times 3x is 12, and x squared times x is x cubed. That's going to be negative 6x squared, 15x, negative 4x squared, 2x, and negative 5. We need to combine the like terms, which I'll underline in color code. And when you do that, you get 12x cubed. The reds add together are negative 10x squared. The purples are 17x and minus 5 at the end. I just ran out of space there. So you see that answer is B. For the next one, we're going to factor out using greatest common factor. The greatest common factor of 18 and 30 is 6, but don't forget the variables. There's an x on both of those, so we can put 6x, and there's a y. Because there's an x, though, that doesn't have a power and a y that doesn't have a power, then the greatest common factor we can do is only an x and a y. We can't do x squared. So we write down 6xy. What you're multiplying by is the same as if you were to divide that out. That's what factoring out means. So if you're having trouble with the GCF and what's left over, you can write down the division problem of dividing out the factor. When you divide that out, 18 divided by 6 is a 3. X squared divided by x is x, and y divided by y is 1, so we're left with 3x. 30 divided by 6 is 5, x divided by x is 1, and y squared divided by y is y, so we get 3x minus 5y. Notice that's B. Number 5. This greatest common factor of the coefficients is 8, but notice how there's an x on all 3 of those. I also can look at my answer choices to help guide me. Instead of wasting time finding the GCF, notice all those answer choices have an 8 on them. So I'm going to write down the 8. The thing that's different, one of the things that's different is whether an x can be factored out and what are the powers of those coefficients. So for example, the first one, some are cubed, some are squared. We notice there is an x on all 3 terms, so you can factor out an x. So 8x gets pulled out. When you do that, and you notice that can't be a and b now, when you do factor out the x, we're dividing 8x out of all 3 of them, we get 2x squared minus 3x plus 4. So the answer is going to be C. D would be if you forgot to remove the x from all 3 terms. Now, on the next one, we're going to factor using the difference of squares. Remember, this is the parentheses, and the plus and the minus is the setup. So let's do this first one. You have to square root the first and the second to find out what goes in the parentheses. So the square root of 9w squared is 3w, and the square root of 25 is 5. So I'm going to set it up. In each of the first slots, the first term of each binomial will be 3w, and the second term of each binomial will be 5. Over here, I'm going to set up the same way. I'm going to do plus and minus. The square root of z squared is z, and the square root of 1 is 1, so I'm going to have it written like that. Down here, part D, factor the polynomial using trinomials. This is the one where we're going to write factors of. So, factors of 36 for number 8, because that is the c term, or that's a times c. Factors of 36 include 1 and 36, 4 and 9, 6 and 6, and 3 and 12. Notice, if I forget some of these, I could look at the answer choices again to help guide me. You see how those three show up on the answer choices? All right. Now, to use this, we need to think what adds to 15. Be very careful that you don't just pick the numbers that add to 15, because 10 and 5 add to 15, but they are not factors of 36. So, I'm going to draw a box. X squared goes in the top left. 36 goes in the bottom right. Oh, sorry, 3 and 12 are the ones that add to 15 and multiply to 36. So 3x and 12x go, fill out the box. We get 3 there, x there, and a 12 there. So the answer is x plus 3 times x plus 12. All right, for number 9, factors of a times c. So that's 3 times 4, that's factors of 12. Let's see, there are lots of factors of 12, 1 and 12, 2 and 6, 3 and 4. We can stop there because 8 is what we're trying to add up to, and 2 and 6 add to 8. Now we're going to draw the box, fill out the first term and the last term. Our 8b will be split between 2b and 6b, and we're going to factor those numbers out. So we get a 2 there, a 3b there, a b up there, and a 2 up there. Oops. So the answer to this one will be 3b plus 2 times b plus 2. One last comment about all these factorings. If you are stuck, you can always multiply back out each of the answers and try to find which of those equals the original solution. You have to be careful about this though, because especially with the GCF ones, there might be more than one that works, but if you don't factor out everything, you don't find the correct GCF. Here, we have some mixed review. So factor this completely. What we're going to do is we're going to factor out a 5 out of this and x, and that gives us, well, we divide 5x out. For the first term, you're left with 2y, and for the second term, you're left with 5. On number 11, you need to find the GCF first. Remember, that's always the first step. When you do that, this becomes a much simpler problem. So you notice there's a 3 in all 3, 9, and 30, but there's also an x, so we need to take 3x out. Once we do that, we'll divide out 3x, we get x squared minus 3 times x. Divide out 3x from 30x, and you get minus 10. Now, this we can also factor. So if you ignore the next step, you're ignoring the word completely in the instructions. B is not correct because it is not completely factored. Yes, it's equal when you multiply it back out, but it is not completely factored. So let's write that down there and let's factor it. We're going to write down factors of negative 10 that add up to negative 3. And I believe that we have found it. 2 and negative 5 add up to negative 3. So those are what we're going to fill out the rest of the box with. We put 2x and negative 5x, and factor out an x, factor out a 2, factor out an x and a negative 5. So our answer, and part of it is x plus 2 times x minus 5, but don't forget the 3x. So 3x times all of that is our final answer. C is the answer, even though the two factors are switched in order. The order does not matter when you're multiplying. For the last two questions, we need to solve the following quadratics by factoring. These, when I say solve, that means find the zeros, or the solutions, or the roots. And these are also a special kind of problem where you're selecting all that apply. Now, the first one we need to factor, so we're going to find factors of 45 because it's already set equal to 0, so that's good. Factors of 45 include 1 and 45, 3 and 15, 5 and 9, but notice we need them to add up to negative 14. So that means I'm going to put negatives in front of all those factors, and the two that add up to negative 14 are negative 5 and negative 9. When I find the GCF, I have to be very careful because it might look like 5 and 9, but we have negative numbers there, so I need to make that negative 5 and negative 9. That means our factors are y minus 5 times y minus 9, and that's equal to 0. But we're not done yet. The last step, remember, in finding a 0 is setting each factor equal to 0. So y minus 5 equals 0, and y minus 9 equals 0. Solve for each equation, and you get y equals 5 or y equals 9. Those are our two solutions. So you need to circle C and D. Notice how A and B are the lazy approach if you assume you're done at that earlier step. So circle all that apply. For this last one, it's a reminder to check the GCF first. And when we do that, we notice that 4a can be pulled out of the 4a cubed minus and 36a. When that happens, we get a squared equals minus 9 as a factor, and you should recognize that immediately as a difference of squares because a squared is squared, and 9 is squared. So we factor out the difference of squares. No need to draw a box for that. And we get three different factors. 4a equals 0, a plus 3 equals 0, and a minus 3 equals 0. Solving for each of these gives us a equals 0, a equals negative 3, and a equals positive 3. That means that there are three solutions we have to circle here: B, C, and D. Now, one last note about these problems here in letter F. Because they're solving or you're trying to find the solutions, the answers, if I give you multiple choice, you can guess and check. Try each of these problems or each of these answers and see which ones give you, when you plug them in for the y's, which ones give you a 0 in the output. I would not recommend it because it's a slow process, but worst case scenario, if you forget how to solve these, you can work backwards at least on the multiple choice answers. Thank you very much for watching.